Hi, everyone. Thanks for being here with us today. Welcome. We're just going to give it a few more minutes as folks slowly trickle in. So grab a coffee, grab a water, grab some snacks, and we'll get started in about 2 minutes. Still seeing lots of people come in. Welcome, welcome. We're happy to have you here with us today. If you're just joining, we're gonna get started in about a minute or so. So settle in, grab some water, and we'll get started soon. Alrighty, we're gonna go ahead and get started. So, hi everyone, I'm Zelene and I'm from Product Marketing on Heroku. I'll be your host for today's session. We're super excited to have you all with us as we dig into this next chapter of Heroku together. Welcome to today's webinar on Heroku AI PaaS. We'll be talking about Heroku AI, which recently went generally available, and that includes Heroku Managed Inference and Agents as well as MCP server. So before I dive in, legally, I'm required to say this. It'll be real quick. We might talk about some ideas that look to the future. These are forward-looking statements, which means they might change. So as always, make any decisions on features that are available today and not in the future. And with that, I'm going to quickly introduce our speakers. Today in the room with us, we have Rand, our Senior Director of Product Management, who will walk us through Heroku AI and what's new. And we also have Julián, our Principal Developer Advocate, who will show us how it all works and bring it alive with a live demo. On the next slide, our agenda, here's what we've got planned over the next 45 minutes. So we'll start off with why AI on Heroku and just what it's all about. And then we'll dive into a live demo, which includes how we've created this user experience across the platform, how to actually get started with Heroku AI on Heroku, an overview of the key components of Heroku AI, and how to actually use it and extend it using MCP servers. And finally, we'll have time at the end for dedicated Q&A. You'll see a Q&A box at the bottom of your screen. So if you have questions as we go, feel free to drop your questions in the Q&A box, and we'll have plenty of time at the end to address them. One more housekeeping item, the session will be recorded as well if you're not able to make certain parts, so we'll send it out afterwards. And with that, I will hand it over to Rand to kick us off.
Greetings, friends. I appreciate you all joining today. AI is a special moment in time for a lot of the software industry, and it's changing how a lot of us do business. But this has happened before, or at least things that rhyme or echo. We've had various inflection points where new technology emerges that is super desirable to use, but also sort of challenging to operationalize and move forward with. Back in the day, Heroku took on that challenge with making it easy to deploy and scale applications, starting with Ruby on Rails, but Git push Heroku main really changed the game in terms of how to think about deploying, scaling, operating over time. Uh, So we often hear the question, like, who's going to build the Heroku of AI? Who's going to bring this level of developer experience and operator experience to the actual building of AI applications and agents, or building with AI in a supportive manner? Well, happily, the answer to that question is Heroku has, of course. Why would someone other than Heroku build the Heroku of AI? So, why are we taking this challenge on? Building AI apps and agents can be super challenging. There are a plethora of models out there, and you have to optimize between the data sets that they were trained on, their inference speed, their efficiency, the modalities involved, what kind of embedding models they work best with, just a huge range of questions that often require more expertise than folks have to be able to field in teams on those projects. And that's before you can get to actually integrating these with your applications and focusing on the actual business value you're trying to achieve. And then if you want to make these super relevant and actionable for your business, you've got to make sure that you've got secure access to that data that is going to be part of your critical workflow. And then managing it over time is still sort of an emerging art for many people. Managing AI, managing its performance, managing its efficacy, managing its accuracy. And we try to obviate most of those pain points by providing an opinionated, curated approach to building AI applications and agents, all as part of Heroku's integrated platform. So I'm sure all of you are aware, since you're here today, but Heroku provides an amazing environment for your data, applications, compute, tools, user management, workflows, and even your operational processes with things like pipelines and review apps. Bringing all of that together and extending those awesome DevX and OpEx capabilities with AI is what we've done. Now it's as simple as Heroku AI models create to provision secure access to a curated set of world-class models for use in your applications. And we've extended it all with MCP, or the Model Context Protocol, which allows you to really cleanly and safely extend a lot of your AI and agent applications with either the code you've already written or with tools and resources that have programmatic APIs in them. So, bringing these all together, we've got a really robust solution for building AI applications where you can focus on the actual value of your work as opposed to having to dive deep into every particular corner of the new ecosystem. So, we're often talking about Heroku as an AI PaaS these days. What does that mean? So I'd like to challenge people to think about an AI PaaS in a couple of different ways. One, we provide the primitives and experiences that make it easy and safe to build and operate AI applications and agents, or you know, systems that actually use AI in their operation. We also use AI to facilitate how you build applications and run things on Heroku. So it is an intrinsic part of the platform itself. And last but not least, we have also exposed the platform itself via MCP to agentic workflows so you can actually use AI to help drive your automation and ops and deployment. So across those three different spectra, we've really taken the awesomeness that is Heroku, which already provides you an incredible developer experience, really streamlines how your teams can work, and has huge trust across the enterprise sphere, and made it broadly accessible and super useful in all of these key AI domains. Very concretely, a couple of the pieces that are front and center in the new Heroku AI releases. Heroku managed inference and agents. So again, this is what's going to provide the core of access to inference and embedding models of a constantly updated set. We're actually adding an additional one today. But it's not the full panoply of things you might see out there. It's things that we have tested, that we trust, and that we think are optimized for the business problems that our customers are trying to tackle. Managed inference and agents also includes a really great control loop that allows you to integrate very closely between AI and the compute environments, dynos, that we have within Heroku. So if you have a need to do something dynamically where you're asking uh, your AI to query a website or write an arbitrary SQL query, you can actually execute that safely and securely in Heroku dynos. And it's also super extensible via this next piece, which is our model context protocol. We have added a bunch of abilities with MCP. So not only do we make it super easy to bootstrap your own MCP servers on Heroku and extend your own existing applications or new applications with MCP, but we've also added a number of affordances to make it easy to register and access those from other systems. So we've got a lot of great things there. And as I mentioned before, we've also exposed the Heroku platform via MCP itself. Last, but certainly not least, this is actually something we've had in market for a little while, but deserves an additional shout out. Heroku Postgres, which is the cornerstone of Heroku's data strategy, has been extended with PG Vector. So PG Vector is an amazing vector database, which allows you to do things like retrieval augmented generation, i.e. vector similarity search as a piece of the AI generation pipeline that allows you to really fluently and accurately access your data during key AI workflows. And to give a really beautiful walkthrough of a lot of this and provide a lot more depth, I'm going to pass it over to Julian.
Of course, thank you so much, Rand, for this beautiful introduction, and welcome you all to this presentation about our new AI offerings. Well, I am going to be showing you all the technical details behind this. How can you provision an AI model to an Heroku application? We will see how to deploy MCPs, attach the MCPs to the application, and a full demo of how this interaction between inference and agents looks like on Heroku. So, Rand mentioned it earlier. Everything that we do thinking about the developer and that developer experience. And this is how are we going to start. As a developer, how we will provision an AI model to my application. And of course, this is going to start from the CLI. So here I have my terminal. I already have the Heroku CLI, and I installed the Heroku AI plugin, which is the extension that will allow you to manage the AI models from the Heroku CLI. So first, let's take a look at the available models that I can provision to my application. So I'm going to be calling the AI models command. And there we have the list of the different models that we provide. We can see that for inference or text-to-text, we have the cloud models from Anthropic. And as Rand mentioned, today we released Cloud 4 Sonnet. We also support Cohere for embeddings. This is to build retrieval augmented generator applications to store vectors in pgvector. And we also support a Stable Diffusion for image generation, which is the text-to-image model. In order to provide one of those models to an application, we need to have an application first. So let's, here I have a application that is still not on Heroku. So let's create that application on Heroku first. So I'm going to be creating this application. Let's call it Heroku Mia app. Yeah, I like that suggestion. And now that I have the application created, I will be able to provision a model to that app. So I can do this two ways. I can still use the Heroku CLI, or I can go and use the dashboard, the same way we provision add-ons either from the Heroku dashboard application or from the Elements Marketplace. First, let's do it from the CLI. I'm going to be using the same AI plugin. I'm going to be creating a model. For this example, I want to use the most recent one that we published, which is Cloud Sonnet. I'm going to be attaching it to the application, which is the Heroku Mia app. And I can specify an alias if I want to have like multiple models living in the same application, or use the one that it's come by default. And that's it. Now I have access to my Cloud 4 model within this Heroku application. This is going to do three things. This is enabling three configuration parameters that I can use on my application. One is the inference URL, which is the API URL that I will hit to do inference. The other one is going to be the inference key, or the API key that I will use to perform inference operations. And the other one is the inference model ID, which is going to have like that key that represents the model. Since applications can have multiple different models, I will be able to rely on the different configuration variables that this model provision gives me. And to test that this works, I can also perform an inference using the CLI. So let's do Heroku AI models call. I provision inference is the by default alias. I will specify the application and the prompt that I will ask. What is Heroku? So I'm performing basic inference using the Cloud 4 model that I provision, and then I will get the response on the CLI. But we want to do this from an application. We want to take a look at how can we integrate this within the app. So here we see the response. Fantastic. Now let's go back to the Heroku dashboard. Let me show you also how can you provision a model from the Heroku dashboard, and show you how can you deploy MCPs and use inference on an application. So go back to the browser. Here, I am on the Heroku dashboard. I have two pre-deployed MCPs that I will use later, and I have an application that already has a Cloud 3.7 model provision. But let me show you how can I provision a model from the dashboard. So I can go to Resources tab, search an add-on. You will search for Heroku Manage Inference and Agents. And here it will give you the option to select the model you want to provision. You might notice a note here that says that these models are metered. This means that we are charging by the token. So let's provision Cloud 4, submit the order form, and that's it. Now, this application have access to both Cloud 3.7 and Cloud 4. The same developer experience that we have for the other products that we offer, you can have it on this new managed inference service. So I mentioned that we can also have MCP support for these inference. You can deploy your own MCPs, use them on your inference operations, or also expose those MCP to external applications through the toolkit integration. So this becomes Heroku a great platform to deploy MCPs and expose them safely to the world. So far, we don't have any MCP server enabled here on this application. I will show you later how to deploy, how to attach it. But let's start trying out inference, how we can perform inference operations using the API, and how can also perform agent operations using the tools that we support. So we have an application here. This application works similar to other chat applications that you can find out there. This is set up to use the Cloud 3.7 model. I'll show you here in the configuration. I have access to the Cloud 3.7 model, the API key that I already have for my application. And I can perform manage operations. So let's say explain Heroku manage inference and agents in simple terms. This is going to return the response in Markdown, render it here, as a stream. But how we did this request to our inference service? So if I click here to request, this is showing the body of the HTTP request that I am sending to my API. So I have the inference URL with the chat completions endpoint. The chat completions endpoint is the inference API endpoint that you can use for basic inference, and it has an OpenAI-like shape. So you can use OpenAI compatible clients to perform operations to this endpoint. So here I am sending the request body with the model ID, the different messages that I'm sending, in case you want to send multiple messages to keep some sort of context or memory of the conversation. And I'm specifying that this is a streaming message. So it's going to start returning all the responses as a server sent events. So I will process it as you saw on the screen, kind of like a real time as the response come. So that's how I do basic inference. But the most interesting part of managed inference and agents is the agents part, the tool execution. So we natively support tools for code execution on Heroku, document operations like transform HTML to Markdown or PDF to Markdown, database operations, so you can give access to your inference model to perform queries to your database, and also execute commands on a dyno. So it is perfect to perform untrusted code execution, like LLM generated code execution on a dyno on a safe way, and also trust code execution by running a command on your dyno. So let me show you that agent part. So let's select the agent option here on the sample application. And here I can select different tools that I have available for this demo. The code execution, so far today we support Python, Node.js, Ruby, and Go. So code that is generated by the LLM can be executed on a one-off dyno. Also including dependency installation. If you are creating an application that requires some dependencies from the internet, like a Node.js application, we'll install those dependencies using NPM, or a Ruby application will install those dependencies using gems, and execute these on a one-off dyno, get the result, and then the dyno go to sleep. So you are only going to be charged by the time that that short application run. So let's perform these two examples that we have here. Write a Ruby program that calculates the SHA-256 hash of the string Heroku AI is alive. So this is asking now the agent's endpoint to perform this operation. Now it knows that it's going to perform a tools execution operation, and it will execute that code exec Ruby. So let me check the details. This is how the code exec Ruby tool works. This is basically an MCP that we support natively. It generated this Ruby snippet. And then after executing this on a one-off dyno, we get the response. This is the SHA-256 hash for the string, and it performs if inference operation over this result. But let's do something more complex. Let's do a tool chaining. So for the second operation, we are going to fetch a page from Wikipedia using the HTML to Markdown tool. In that page, there is a Python snippet for the Chudnovsky algorithm that will let me calculate the first position of pi, the first digit of pi. So first we are going to fetch that Python snippet using the first tool, and then we are going to send that code to the code execution Python tool and get the result. So here we are performing the two calls. First is using the HTML to Markdown tool. It got the result, so we can see the Wikipedia page in Markdown here. And then it's going to perform the other operations, send that Python snippet to the code execution Python and get me the result. So now we are running code execution Python. This is the result. This is the value of P. This is the first 60 digits, the first digit of P. And then it's going to explain the result. Beautiful. So we can see the code that it fetched from Wikipedia. And this is the Python code using the Chudnovsky algorithm. This was executed on a dyno, get the result, and then pass that result to the inference. How does this request looks like? We can click here on the request tab. And similar to what we did with basic inference, but right now we are calling the agents endpoint. We send the inference question, and we specify the tools to execute. So for the Ruby one, we are sending the code exec Ruby. And let me refresh here, do the Python one to show you the request. And for the Python one, we are sending the two tools. One is the code exec Python, and the other one is the HTML to Markdown. So depending on what you are asking to the model, it will perform the tool choice and start doing that inference. But remember that I mentioned that you can also add MCPs to inference. So now let's take a look at first, how can we deploy MCPs to Heroku? And second, how can we attach MCPs to my inference service? So here I have a MCP. This is the Perplexity Ask MCP. I fork this from Perplexity in order to add the Procfile file. So the Procfile file is what we use to define the process to execute on Heroku. You might be familiar to it. When you are running a web application, you define the web process and the script that is going to be executed. But for MCPs, we have a new special type of process, which is the MCP process. So the process that starts with MCP is going to be identified by our platform and treated as a standard input and output MCP, like a local MCP that will run on this dyno, on a one-off dyno when this tool is going to be executed. And since I'm going to attach multiple MCPs to my application, we use this process type also as a namespace. So it is recommended to keep this process name unique. So I'm calling this MCP Perplexity, and for the other MCPs that I have on my application, I have my own unique name, but it needs to start with MCP. And then I'm executing the binary or the script that the MCP uses. In this case, is the index.js. So let's deploy this to Heroku. I'm clicking to deploy using the Heroku button. Let me call this Perplexity Ask MCP. The name is available. I'm going to be installing it on the Mia Demos team, which is the one that I'm using today. And the API key for the Perplexity service, I'm going to be changing it later. Let me deploy this application. And it will perform the basic deployment that Heroku supports. Send the code to Heroku. Heroku is going to install all the dependencies, build the container image, and then keeping this application there waiting to be executed by our inference tool. So once it is deployed, we can see that it detected the different process types, and we can see here the MCP Perplexity. Now let's go to our Heroku dashboard. Let's go back to Mia Demos. We can see that the Perplexity Ask MCP is deployed here, and I already have two MCPs available here. We have Brave Search to perform search using the Brave API, and the MCP exec Python. As a matter of fact, the code execution tools that we support natively, we also release those as open source MCPs that you can use external to Heroku. I'm using that same MCP to show how to use custom MCPs with inference. But this is the same that you are going to find natively on our agents endpoint. So let's enable those MCPs into my inference service. Let's go to inference demo. Open the dashboard configuration for the 3.7 model. Click on Manage MCP Servers. And here I'm going to be attaching the service as is another app. So let's search for Brave Search. And let's add Perplexity as well. Let me refresh. So now we see that it detected the MCPs. One is still disconnected. It has not detected the tools, but the other one, which is the MCP Brave, which was already configured, it imported two tools. Behind the screen, I'm going to set up my official Perplexity API key to my application. And then, did I execute this? Yeah. Then let me go to the toolkit. And here in the toolkit, we can see now the tools that we imported. We imported the local search. This is for searching local businesses and places using the Brave Search API, or web search is to use the Brave search engine. And let me refresh to see if Perplexity has been imported. Now we have Perplexity Ask. And if we click these tools, we see pretty much what are the inputs that this tool expects. For example, Brave Web Search expects the query as a required input and the count, the number of results, and another parameter for pagination. So now my agent's endpoint have support for these MCPs. So let's go back to our demo application here. Let me refresh the list of MCP tools. Seems the application is having a problem. And is not getting the MCPs. So fantastic live demos. You can see it is live because something is failing right now. But it's okay. We can continue with this demo. There are like the other tools that I didn't mention, like the PDF to Markdown. So we can ask to go ahead and read a PDF from the internet in case I'm going to be using this white paper from Anthropic. And let me ask here to summarize this document. Ah, now I know what it is. So give me one moment. I'm going to restart this process because it seems.
While Julián is fixing that real quick, I just wanted to
Yeah,
call out that this is an amazing capability to be able to quickly add things into your AI or agentic stack. So if you've already got custom logic you've built and you really want to be able to exercise it from AI, it's super easy to add one of these MCP interfaces on top of it. Or if you want to be able to access an existing tool out there, whether it be a database type or an external SaaS provider, as long as there's an MCP that you can actually run, we will register that as part of your service, make it attachable, and it will show up in that interface. And very simply, you can compose your application using those sets of tools.
beautiful. 1 second. I update the API key.
Also, live demos are the absolute best because even when there are occasional bumps in the road, like this is all real. This is all in production. We have people using these for real development, real production, real business use cases.
Yeah, perfect. Let me now restart the demo to get the proper inference key. If not, I have more demos to show, so that's not a problem. Yep, it keeps complaining about that API key, so I will continue with what I have here. So I have another application that is also using an MCP. I have a customized version of the code Python execution. And this is a demo that we built that now uses the inference service in two ways. One is a headless way. We are pretty much calculating the energy savings that we will have on a week, depending of a weather forecast. So depending of the system that we select, this is for a solar energy company. Depending of the weather forecast, is going to see if we are going to have like an effective system that week, and is going to use AI for that. And also we have a chat that you can use to ask questions to your data. So here I am performing a question. Let's calculate the average energy consumption by day and create a visualization. It uses now the other tools, the PostgreSQL get schema to get the shape of that database, the PostgreSQL run query to get the data, and then pass all of that data to Python code to create a visualization. So for creating a visualization, it's going to use Python libraries like matplotlib, NumPy to perform calculation, and then it gives the inference response. Then I got the calculation and the graphic that was generated by the inference service. And here it analyzed that there were a brief period of lower consumption during May 26 and 28. So we see like a dip in my graph. So this is a great way that you can attach inference to your application using real data to perform analysis on the fly. This is not a report that already exists. It's just something that I ask of on my chat application. And what are we doing on time? I think that's pretty much it. I think we can continue now for the wrap up and Q&A. And in the meantime, if I'm able to fix the issue that I have with my demo here, we can show the MCP part later. Sounds good?
Thank you, Julián.
Thank you.
All right. So there's a lot to unpack here. We've added some amazing new inference capabilities, an awesome agentic control loop, great native MCP tools, as well as extensibility for all of the MCP tools that you might want to add into your agentic ecosystem, as well as exposing the platform itself via MCP so that you can use it for things like vibe coding or automating your operations. So there's a lot there. Where do you get started? So Heroku.com/AI is a great entry point, as is our Dev Center documentation. We have provided really thorough examples of how to get started and information on all of the different models and services that exist. So this is available in GA and is being widely used. So please kick the tires. Let us know how you feel about it. Let us know if you have any questions or updates that you'd like. And stay in touch. We're going to be releasing a lot more in this same vein. This is not the finish line. This is the starting line. So let's have some fun. Thank you all.
Thank you, everyone. We're going to move into the Q&A section now. So we've got some great questions. I'm just going to bring up some of the questions, and we've got our PM team, Anush here as well, and Rand and Julian to help answer some of the questions. So one question we got was someone asked, what advantages do I get by using the Heroku managed model versus directly speaking with, for example, the Anthropic API endpoint with my own key? And related, how does pricing compare?
I can take a swing at the first part of that. So, we work really closely with a lot of our partners out there, like Anthropic or AWS for their Bedrock service, and we offer the same models that they do. And we make sure that the models offered through the system are, again, well vetted, well tested, and well understood and optimized for our customers' use cases. The primary differentiation is honestly the deep integration with the rest of the platform. So you can get inference from a lot of places right now, and these places are extremely good at what they do. But when you actually want to build AI applications and agents, being able to connect those things seamlessly and securely with a compute environment, your data, and a wide variety of tools in a way that you can actually scale, understand, and operate over time is not something you're going to find in a lot of other places out there. So Heroku really is not trying to compete directly with those inference providers. We're trying to provide the platform aspect that makes it a lot easier and more focused to build AI applications and agents and scale them for your use. And as for the pricing, again, as Julián mentioned, we do charge by token, just like is typical for most of the inference providers out there. There's a slightly different rate for input tokens versus output tokens. Again, that's industry standard. We're pretty much on par price-wise with our competitors or other partners in the ecosystem. That's again, we're trying to encourage use of AI. We think that the differentiated part of our offering is being able to connect it to your compute, your data, and your tools within the platform.
Thanks, Rand. We've got one more question. Is the model running inside of Heroku? Is the data ever leaving the application?
So, as I'm sure most people here know, Heroku runs on top of AWS. Like that's been a part of Heroku's story forever. We have a deep relationship with AWS and a great shared responsibility model for our security. And inference is currently run by AWS Bedrock. So that is tightly coupled to the calling customer's account for that inference operation. This is no different in terms of data exfiltration as you would see with storing something in Heroku Postgres. So it's all within that account control environment with a high degree of security and trust.
We've got questions pouring in, so I'm going to try to tackle as many as we can. Will a graph database be added, or is it limited to a vector database on Postgres?
So PG Vector is the only first-party vector database that we offer right now. And we are looking actively at graph databases, but I can't promise anything in terms of delivery of a first-party option in that time. We are also trying to look at additional partners in the ecosystem that might be well-vetted parts of our Elements marketplace. I've used graph databases for many years and love their application in graph retrieval augmented generation. Definitely see that demand, and we want to make sure that we can accommodate that over time.
Awesome. We've got a few questions around security, Rand. Can you talk a bit about, in terms of security, what are the features in Heroku to handle, poison training data, secret credentials exposure? How should users understand and plan to mitigate any risks from MCP protocol?
Right. So let's tackle that a little bit piecewise. In terms of poison training data and sort of prompt injection attacks, as I mentioned, we are working very closely with our partners at the various model providers as well as within AWS, and only offering a very select set of models that we have tested and vetted to have appropriate safeguards in place at model inference and execution time. So a lot of that is handled with safeguards and tests deep in the inference stack. We do not currently expose external pieces of that to customers, but we're looking at additional ways to expose some of our safeguards to customers to have it more visible. Excuse me. As far as making sure that you're not getting data leakage or sending sensitive information to the AI, one of the nice things about Heroku is that pretty much everything is exposed as config vars or environment variables. And the same thing happens when you expose tools and credentials into your compute environment that you're using with dynamically AI generated code. So you send a request to the AI, it doesn't get your credentials. It generates some code, sends that back to a dyno, which is again our secure compute environment, where the configuration data that you need, the sensitive data, is going to be hydrated into the execution code, run, and then securely torn down. So we've got a really nice, scalable, predictable system for passing that data around without exposing it or leaking it to AI providers.
Thanks, Rand. We've got a few questions as well around if there's any plans to support a wider variety of LLMs, such as Llama and DeepSeek.
So we've actually supported a number of those over the time this has been in development. We're trying to optimize for the ones that we think offer our customers the highest level of efficacy for the use cases that we've identified. We will be adding, and as Julián showed, we are adding even today, additional models over time as we go. So we will always offer a curated selection because Heroku is a rather opinionated platform, and try to keep things focused on providing actual value as opposed to not necessarily the newest and shiniest that we might see on Hacker News or Hugging Face. But that's because we care about making sure that AI applications and agents are easy to build, safe to operate, and scalable. So as new things come available within those criteria, we will be adding them.
Sweet. And we've got some really great questions actually around connecting Heroku and Salesforce with AppLink, as well as how this all works with Agentforce. Is there anything you can say to that, Rand?
Yeah, so AppLink, for those of you who don't know, is our great system. It's currently in pilot or beta. It will be coming GA very soon, but it essentially allows you to do really simple bidirectional mapping of accounts and contexts between the rest of Salesforce and Heroku, making it so that you can expose your Heroku applications and logic very cleanly and simply into those operational contexts. And one of the ways that we see a lot of usage of that right now is by extending Agentforce. So Agentforce is, again, Salesforce's broader agent solution, provides a lot of great business-centric capabilities, and a lot of what agents can do in Agentforce are called actions. So there's a plethora of actions out there that can do a lot of amazing things, but there's always a long tail of needs. If you need to implement something that is not represented in the available actions, or want to be able to re-leverage your existing code but surface as an action in Agentforce, it's super easy to take applications on Heroku, extend them via AppLink, and expose those endpoints as actions in Agentforce to really round out your portfolio while keeping it all within Salesforce's deeply unified platform. As far as how managed inference and agents plays into that, if you need agentic capabilities on the other end of that agent that do bespoke things, that's a great solution. But really, anything we expose as an application on Heroku, whether it be AI or not, can be exposed via AppLink into these new environments within Agentforce, Data Cloud, and elsewhere.
Cool. We're over time now, but there's still so many questions. If you got one more minute, Rand, we've got a few more. Rakesh asked if there's any plans to add forecasting models.
So specific time series models, we are looking at that. Again, this comes down to availability, scalability, security, trust, performance. We know it's high on the wish list for a number of people. You know, that said, I have seen anecdotally and personally a high degree of success using things like Claude 3.7 and Claude 4 for time series prediction. Um, so while we see customers using that, we do understand that there is desire or appetite for specific time series prediction models, and we will keep you posted on that.
Alrighty, we are officially over time now. Thank you so much, everyone, for attending. We loved having you guys here today. Thank you, Julian and Rand, for the awesome demo and overview of Heroku AI. And as we said, stay in touch. We've got a lot of awesome upcoming webinars coming for Heroku, a lot of awesome stuff coming. So have a great day, everyone, and we'll be in touch.
Thank you
Bye,
all.
all.
See ya.